right, so what was it, Friday? We kind of did like a little law cosines lesson. And maybe I will do that again since the audio didn't work on it. I think all we did we actually, yeah, we did some examples with it, didn't we? Right, actually used it. Did we find the angle, like angle C? Did we do that too? Did the inverse cosine? Okay, so we did all that. So, I mean, well, since there's no audio on it, maybe I will teach it again, but maybe just go a little bit faster, just so that it's there. So if anybody was absent, at least they can't say, well, I don't know how to do it because there's no audio on it. So, yeah, I think we'll still do that. We'll probably do that tomorrow, all right? Instead of the ambiguous case, we'll probably do the law of cosines tomorrow. And then if you're not here Friday, then we're all good, and we should be able to stay on track. All right. Did we derive the law of cosines? I think we did, didn't we? Didn't we do a whole bunch of stuff? Yeah, I think we did. We're going to do the same kind of thing with the law of sines. This one, I think, is a little bit easier. I'm doing it a little different than the book does. I looked at how the book does, and it made sense, but I think it's going to be a lot more difficult for you to understand how we derive that one compared to this one. Because when somebody comes up with these formulas, it's not always just one way to do it. Like Pythagorean theorem, there's all kinds of ways. I mean, like more than dozens. I think I heard somebody say there's like 100 or more ways to prove the Pythagorean theorem. It's crazy. I don't know if you heard this, but a couple 3 years ago, these two high school girls down south somewhere, Louisiana, I think, something like that, they actually came up with a brand new proof to the Pythagorean theorem that nobody had come up with before. And these are high school girls. And it's pretty cool. If you look it up, high school girls prove Pythagorean theorem on YouTube, and you'll see a lot of news stories that people have done about it. It's pretty cool. And it was just like a couple 3 years ago, I think, that they did that. So even today, people are coming up with new ways to prove things and coming up with stuff. So I think that's kind of cool. So today, what we're going to do is we're going to derive the law of cosines. Now, I could just sit here and say, okay, this is law of cosines, and you probably would appreciate it more if I just told you what the formula was and how to use it. But you guys are upper level students, right? You're honor students, so I think this is something that you can see and maybe have an appreciation for, and some will not, but that's okay. I'm going to show you anyway. All right. That looks like an equilateral triangle, but it doesn't necessarily have to be. This is just some general triangle, and I'm going to call it ABC, A, B, C, and this would be side A, this would be side B, this would be side C. And then what we're going to do is put a height on here, and we're going to take this, we're going to drop this perpendicular, so that would be the height. All right, we'll call it H for height. All right, everybody good? All right. So we're going to come up with this thing called the law of sines. I'm not even going to show you what the law of sines is until we actually get to it, okay? We're going to actually come up with it. Hopefully this will make sense. Is this something you have to do on a quiz or a test or anything? No. All right, but it's just, I think it's good as a math person to be able to see where a lot of these things come from. Sometimes they're way too difficult to understand where they came from, so they just throw it out there and they say, this is the formula, just learn it, okay? But I think in this case, I think this is definitely something a high school kid could see. So first thing we're going to do is take a look at this right triangle right here. Since it is a law of sines, what we're going to do is we're going to take that angle and we're going to take the sine of that angle. All right, just because it works. You know, people are going to look at this and say, well, why'd you do that? Why'd you do that? Well, we did it because it works. Okay, that's a stupid explanation, but in college, I remember professors telling us, it's because it works. All right, might try a bunch of things, doesn't work. You try this one thing and it works. You're like, oh, that's why I tried it. Okay, that's what we're doing here. So what I'm going to do, I'm going to write the sine of angle C. The sine of angle C. What would it be equal to? What over what? What's the sine? It's opposite over hypotenuse. So what letters am I going to put here? What's the opposite of angle C? H, right? Over the hypotenuse. What's the hypotenuse? It's A. Good. All right, now what I'm going to do is I'm going to write this in terms of, I want to solve for H, okay? We'll just say it that way. I want to write this, I want to find out what the H is equal to, what the height is equal to, all right? It's pretty easy. Multiply both sides. Yes, sir.
Sorry.
No, sorry.
Alua, for the exam smarts and Miss Diaz room, and you can just add them up for the exam. Just FYI. Alright, sorry, thank you.
No problem.
Now that I realize that.
All right, so we're solving for H. Super easy to solve for H. We just multiply both sides by A, and you get that. Everybody see how we got H by itself? All right, we're going to hang on to that for just a second, and then we're going to do something else. Now you turn to area, all right? So they're going to find the area. And how did you know to find the area? Don't worry about it. They just found the area of it, and you'll see how it works. It works because it works. I know, that's a horrible explanation, but that's right. So we're going to find the area of that triangle, ABC, that whole entire triangle. Okay, not just this right triangle. See, what I was doing right here, I was only looking at this triangle here on the right. Agreed? Now, you could do this for angle C. You could do this for angle A. You could do this for angle B. We're only going to do it with angle C right now, and you're going to see what happens, all right? So how do I find the area of any triangle? What is the area of a triangle? It's 1/2, what? Base times the height, okay? So let's take a look at this big triangle, all right? So what would the area, I'll put area instead of A because you do have a capital A here for the angle. So I'll put area is equal to 1/2. What's the base of this whole entire triangle right here if this is my height? What is it? Come on, talk to me. Help me out. I want to know you're listening. What's the base? I think I heard it. Somebody say it? B. Thank you. All right, so B is the base of that whole triangle. Wouldn't you agree? All right. Now, it just happens to be the letter B. It doesn't have to be B for base. It's not really why it's a B. It's just because it's ABC. All right. So it's 1/2 times B times, and again, well, it is H, but guess what we did earlier? We solved for H, didn't we? So instead of writing H, because we would just be rewriting this again, what is the H equal to? A sine of C, right? So put A and then the sine of C. So that's how you find the area of this. If you knew this angle, right, and you knew this side right here, and you knew this side right here, you didn't even have to know what the H was, did you? Right? That's all you'd have to know. You could find the area of that triangle. So that's kind of cool. Let's write it so it looks a little prettier than this. I don't like the BA. I like the AB. Put it in alphabetical order. You know, it doesn't really matter. It just would be nicer. Wouldn't you agree? There you go. Now, you could do this using angle A instead of angle C. You could do this using angle B instead of angle A and C. All right? And what you're going to do, I'm not going to do that for all three of them. Okay, we did it once. That's all we need to do. So what we're going to do is the area would be the same for all of those. So watch. So 1/2 AB sine C. So I went through all the work to do C. I could go and do all the work to find and have a B in there. Okay, then I could do all the work to find A. But I'm going to show you, there's a little pattern developing. So if I find the area of that triangle, it's 1/2 AB sine C. If I do that with angle B, right, I'm going to have a sine of B. But what's the other stuff going to be? It's going to not be 1/2 AB. So, because this is a C, so I got the other two sides. I don't have side C, I got the other two sides. So if I go sine of B, what do you think the other two sides are going to be? A and C. Good. All right, do it one more time. 1/2. Now, I could do the same thing with angle C, couldn't I? Or I'm sorry, angle A. That's the one I missed. I did angle C already. So what do you think these two numbers are going to be right here? I used A, so what's left over? B and C. Good. Everybody see that? All right. Now, we're almost there. I don't have a good explanation on why you do what you're going to do right now, but it works. All right? So what we're going to do is we're going to divide by something in common with all of these. We're going to divide by a 1/2 a, b, c. Why do we do that? Well, because everything's got a half in it, right? Everything either has an A, B, or C in it. Would you agree? This is AB, this is AC, this has BC. So watch what happens when we do that. So we're going to do 1/2 AB sine C, and we're going to divide it by 1/2 ABC. Now, algebraically, I'm allowed to do that, right? Because whatever you do to one thing, you do to the other thing, right? Or one side, do to the other side, yes? So algebraically, I'm allowed to do that. But you're probably thinking, well, why would you even think about doing that? Because it simplifies things real nice and pretty, all right? So then I'm going to take that middle one, this 1/2 AC times the sine of B, and divide it by the same exact thing, right? I can't divide it by something else. Got to divide it by the same thing, so algebraically it works out. So 1/2 ABC. One more. Then you're going to take that 1/2 BC sine of A, and what are you going to divide it by? The same thing you divided by the other ones by, 1/2 ABC. Now, we are just about ready to get the law of sines. What happens here? Stuff cancels out, right? Since I divided by stuff that's in common with all three of these, so the 1/2 goes, the A goes, and the B goes. So what am I left with over here? Sine of angle C over C equals, what happens here? Bam, those go, A goes, the C goes, so what am I left with? The sine of angle B over side B. Getting the hang of this? Equals, what happens here? Half goes, B goes, C goes, so what am I left with? Sine of A equals, over A. Now what I'm going to do is just, again, that's fine the way it is, okay, but I'm just going to put it in an order that it looks nicer, okay? So I'm going to put it in ABC, all right? So instead of the sine of A over A first, or last, I'm going to put it first. So I'm going to go, if I could write, sine of A over A. What do you think I'm going to do here? Sine of B over B. Just looks a lot better that way, doesn't it? Go ABC. Everybody agree with that? Sine of C over C. And that is the law of sines. I watched a video on this morning, and the girl called it the sine law. Never heard anybody call it that. I've always heard it called the law of sines. But she was British, and she said the sine law. So maybe in British countries, maybe Canada and England and Australia, places like that, they might call it the sine law. I don't know. But we call it the law of sines. Okay? There it is. Here's another way you could write it, and I'll show you why you might want to write it a second way. It's really not that hard. Watch this. Instead of writing sine A over A, you could write it A over the sine of A. You're like, Mr. Hamrick, that and that aren't the same. They're not equal. But if you change everything else, right, if you flip everything else, then everything's still equal. So you could write it, what? Side B over the sine of angle B equals side C over the sine. Sometimes when I say side, S-I-D-E, right, the little one, over the sine, S-I-N-E, of angle C. So here's two different ways you could write it. And there are times where I would prefer one over the other. It just makes life a little easier. You don't have to know them both, but really, all it is, you know one, the other is just the inverse. Super easy. All right, we got one example and we'll be done. How about that? Can you imagine actually getting finished before class is over? Usually I'm rushing at the very end, aren't I? Everybody got that down? So it's weird because you got three things. When you have a formula, you usually have one thing is equal to something else, boom, that's it, right? But now you got three. When you actually do this thing, you're not going to use all three at the same time. You're going to break them up. You're either going to use these two right here, you're going to use these two, or you're going to use those two. Everybody see that? So even though there's three of them, you're not going to do like all three at the same time. You're just going to pair them up. Hello?
Hi, excuse me interrupting. Can you send Hannah Banana down for an early dismissal, please? Thank you.
I don't have a banana in here. All right. Leaving the rest of the week and leaving my class early. I don't know if I should be offended or not, but I'm sure. That's what all the girls told me when I was growing up. All right. Now I got to hear it now. All right. Let's do this. Example 1. Well, there's only one example because there is another example in the book, but I decided not to do that one. See ya. Have fun. You're going cheering, right? Is that what you're doing? Good luck. All right. What's I going to do? Oh, let's draw the triangle first and put some stuff in here. So I'll show you how this works. It is a pretty nifty little formula we've developed here. And they tell you that this angle is 33 degrees. They tell you one up top is 105 degrees. And they tell you this side right here, call it side B, is 37.9. Oops. There we go. And this is triangle ABC. And we just want to find all the missing stuff. So if this is angle A, this is going to be side A. If this is angle C, this is going to be side C. And of course, this is angle B, and across from it is side B. So you would not, without, well, this isn't even a right triangle, is it? So you couldn't even use like sine, cosine, tangent on this thing because it's not a right triangle. You could not even use, I don't believe, you could even, well, yeah, right now you couldn't even use the law of cosines, okay? So, because you got an angle and that, but then you got two variables. So yeah, you wouldn't be able to use the law of cosines with this. So really, the only thing you can use in this situation is the law of sines. So there's one little thing that you don't have to know anything about trig. You just have to know basic geometry to find. What would that be? Yeah, angle C, right? That's what you would find. So it's 180 minus what? 105 minus 33, and that's 42 degrees. So angle C is equal to 42 degrees. All right, that was easy, wasn't it? Yeah. So now, knowing that, you might be able to use, well, you still couldn't use all cosines, but that gives us some options as well. All right. Let's solve. I solve for A first, so let's do that. It doesn't matter. You could solve for C. Yes, you could. You could solve for C, for side C if you wanted to. It doesn't make any difference. Let's solve for A first. So, do you remember the two versions that I gave you? This is a situation where I would pick this version right there, because what am I solving for? I'm solving for side A, correct? So look where the side A is. It's on the top. It's just a lot easier, okay? It really doesn't make any difference. It's use this one or this one, but I think it just makes this a little bit easier, all right? So whatever you're solving for, if you're solving for missing angle, right, I would use this one because the angle's on top. If you're solving for missing side, then I would use this one, all right? So that's why I wrote down both of those. So let's do it. Let's solve for A. So what is it? It's A over the sine of the angle that's opposite. We know the angle is 33, so I'm going to write the sine of 33. And remember, we pair these off. So I need to know 3 out of the 4 things. If I'm solving for A, I got to know both of these. So am I going to, well, actually, I could use any of these. It doesn't make any difference. Well, now you couldn't use this because you don't know C yet, do you? So you couldn't use C. You have to use what? The B, because I know what the angle is and I know what the side is. So if it's A over sine of A, what's this have to, or sine of 33, what's this have to be? It's got to be B over the sine of 105. So what is the B? It's 37.9 over the sine of the angle that's opposite this side, which is 105 degrees. See how we set it up? Remember I said we're not using all three, we're just breaking it up. All right, so we use this one because we're trying to solve for A. We don't know what it is, so I have to use the angle that's opposite. But then you have to know the other angle and side that are opposite each other. Okay, I couldn't use the C in this situation. Why not? I know the angle, but I don't know this to be C. Then I would have two unknowns, right? And I can't do this with two unknowns. So look, I got 3 out of the 4 things. Now this, by putting the A on top, it makes it kind of easy. I used to teach just do cross multiply. Remember cross multiplication? Yeah, but if you put it in this situation, to me, it's a lot easier just to get rid of the sine of 33 degrees. I just watched a video this morning about this when I was watching the ambiguous case. The guy's like, okay, cross multiply. I'm like, oh yeah, I used to do that. But I think it's better to just multiply by the sine of 33, right? Because how do I get A by itself? I get rid of this stuff. What is this stuff doing to the A? It's dividing. How do I get rid of something that's being divided? I multiply. So watch, I multiply by this. I don't have to show it. I know it's going to go away. So then I multiply this side by the sine of 33. Agreed? You okay with the algebra on that? Makes sense, doesn't it? Yeah, real basic algebra. And now, all I got to do is put all that stuff into my calculator. You just got to practice that, just like I talked about the law of cosines yesterday, or whenever it was, Friday. Make sure that you practice using this on your calculator. So once you do that, you get approximately 21.4. It's not exact, so it'll come out approximately. So that's what A is equal to. So we could put that in there if we wanted. Let's do it in red. So A is 21.4. So that's not too bad, is it? It's a pretty easy formula. I think sometimes, a lot of times, it's easier than the law of cosines. The law of cosines can be a little complicated in the calculator. With this, just punch it in. 37.9 sine 33. Then you hit divide. And then sine of 105, hit enter, boom. You should get that answer, 21.4. Make sure you practice that. Try it yourself, okay? I don't see too many people punching in buttons on your calculator. You should be practicing that. All right, let's solve. What do we need now? We need C, don't we? So let's do that. Since we're solving for C, let's put C on top. What are we going to do, though? C over what? The sine of C. We know C now, don't we? It's 42, so we'll use that. Now, we want to pick an angle and a side that are opposite each other that we actually know. Now, we could pick the 21.4 and the 33, right? But the 21.4 is an approximation. So I would rather stay away from that. Now, you could, and it might round to the exact same answer. It possibly could, but it could also be off a little bit. All right, so I would rather not use the one that I rounded if I can avoid it. So what am I going to use then? Use the B's, because I know both of those. So the B is 37.9, put it on top. The bottom is the sine of angle B, which is 105. The math is exactly the same. The algebra is the same. Multiply by the sine of 42. And put it in the calculator, and you're good to go. So you put it in a calculator and you get approximately, again, 26.3. So that's, I'll put a C right here. So C equals that. So there I go. I found all the stuff. So this is 26.3. So those are the answers. I solved that triangle, found all the missing parts. What do you think? So law of sines not so bad, is it? No, not too bad. Now, there are some situations where the law of sines is bad, all right? And that's called the ambiguous case. And I would teach it to you. I really would. I'm willing. But just for the sake of time, I think we're going to skip it just so I can get to the law of cosines. And the law of cosines will be the very last lesson that I teach in here, okay? So that will be it, because then we have a quiz, then we have a test, then we worry about the final, if any guys have to take the final. All right, so that's it. Any questions, comments, anything on that? Now's the time. Did you take good notes? Didn't write anything down at all. Didn't even have a piece of paper in front of you. All right, well, hopefully you understood it, or you watched the video, and there you go. So let's see, I did give you a little assignment, didn't I? Law of sines, 11 to 24. All right, so it's numbers 11 to 24. And this is section 5-6. Yep, there's no part A or anything like that. So that's the whole assignment, 11 to 24. Everybody good?